Chi, thanks for jumping on. It's a pleasure to meet you. I was really excited. Yeah, you're quite welcome. Obviously, like AutoGen is all the rage right now. It's very popular. There's lots and lots of videos being made about AutoGen. But before we dive into that, I was wondering if you could just tell me a little bit more about your time at Microsoft as a principal researcher. Like, how did you get into that position? What's it been like? Yeah, so just give me the story.
Oh, thank you. Yeah, my name is Chi. I'm principal researcher at Microsoft Research. I joined a long time ago. I joined about 9 years ago in Microsoft. And I've been working on many different projects. Apparently now I'm focusing on AutoGen. And before that, I worked on automated machine learning for systems, data science, data analytics, data mining. So quite a lot of different things. And some of the work is more like on the theoretical side, and some of them is more to the system side. I've been focusing on AutoGen recently, so very happy to be here. Yeah.
Excellent. Yeah, with all the progress that's been made on large language models and working on assistants and agents, and then of course working on agents working with other agents, let me ask kind of a big question. Like, what was the genesis behind AutoGen? Like, how was that project proposed? Like, how did it come together? Like, what was the theoretical work behind it, and how did you get from 0 to where you are today?
Yeah, so that's a very interesting question. And to fully answer that question, I need to tell a long story. But let me first tell you a short one. Short answer is like, with this big kind of opportunities with large language models, so powerful techniques, at MSR, we want to ask the question like, what is the future, right? We won't be forward-looking, we won't be futuristic, kind of take the thought leadership. And because one of the famous quotes from the founder of Microsoft Research, Rick Schiss, said, the best science will be indistinguishable from magic. So that's what the level of ambition we have. So we ask the question, what is the future of AI applications, and how do we empower every developer to build them? So that's a fundamental driving question. Now a longer version of the answer is that I started from, as I told you before, I worked on AutoGen. I worked on automated machine learning, which is another open source project called Flammo. Flammo is a solution for automating model selection, hyperparameter tuning, essentially black box optimization to navigate a large search space without knowing the gradient. This is a very powerful technique, but that was started before the large language model takes the storm. And when ChatGPT released, right, and that's a big kind of upgrade of the model capabilities. And so I started working on similar problem as automated machine learning. I started working on inference hyperparameter tuning for these ChatGPT models. For example, how do you select the best model? How do you select the right prompt, temperature, and all the other inference parameters, so that you can maximize the utility from the models while minimizing your cost? So that's initial work on this direction. And when GPT-4 is released, that's another big upgrade of the level of capabilities. So then I started really to ask the question, okay, if we kind of want to bring the best power of the model and really solve really difficult problems, what should be the right way to do it? And agent is apparently a very powerful notion. It's another kind of level of the automation as opposed to the previous automation in the automated machine learning work I did. So that's where they started. Of course, it's a whole new area. The notion of agent is not new. It's has been there for a long time. And I remember back in college, I worked on some like game competition, like building agents that can play games with each other, can compete. But at that time, we were using many of rule-based methods. We had deal with a lot of corner cases and so on. So it's not viable. It's a good notion, but not viable. And these large language models, especially the chat operated models, really make it viable and a reality that we can build new software based on. And to study this new area, we kind of need to think many things from scratch and try to think, try to take some of the first principles and what is the right approach, and basically leverage every lesson we learned from the previous projects, previous experience, but try to add them in, build this one multi-agent framework that is really generic, can support diverse applications. Yeah, so there are many different examples of sources like of inspirations I can give you, but in one nutshell, it's like using everything I learned and also take every feedback I received from everyone and iterate on that, and so that's how we come here today. Yeah.
Excellent. Yeah, no, I mean, there's a lot to unpack there. You know, it's fascinating to me that it started as sort of like an like auto ML, like automating the optimization.
Yeah.
And I can see how going to like optimizing prompts and optimizing hyperparameters and parameter tuning could then lead to the agents, especially like you said, if the idea is thinking to the future, like what is the sci-fi version of enabling application development in the future. So I wanted to follow up with a kind of a two-part question. So in the most basic level, what is AutoGen? But more specifically, what is the vision? Like, what is it that you're trying to solve with AutoGen right now?
Yeah. So yeah, in one word, AutoGen is the multi-agent AI framework, and especially focusing on multi-agent conversations, so that we can connect large language models, tools, and human inputs together to solve complex tasks. There can be multiple ways to understand this. So one way is to understand it as a programming framework for developers to build applications easily with some simple and unified abstraction, so that they don't need to worry too much about the low-level details, but can focus on how to define agents, how to get them to work with each other, and eventually reach the goal. It can also be understood as a tool to kind of scale up the power of large language models and make them even more useful by connecting with other tools, non-large language model tools, or human collaborators, and kind of scale up both the complexity of the problem they can solve, the degree of automation to some extent. Yeah, this is kind of a relatively abstract instruction, but if you think about it, about how people use it, it's quite simple. So when developers build applications with AutoGen, it basically boils down to two steps. Step one is to define the agents, and step two is to get them talk. So as simple as that. Yeah, so we'll try to make it very useful and generic, but on the other hand, we want to have a very simple interface for people to use it.
Yeah, that's exactly the vision that I kind of settled on for my like hierarchical autonomous agent swarm idea. Yeah. But I don't want to talk. I don't want to make it about that right now. It's fascinating that we kind of converged on a very similar like principle. Like let's make the deployment of software as easy as possible. And so there's two things that you mentioned, like layers of abstraction, because I think that's a really good intuitive way of thinking about it. Like in the same way that a Python interpreter was a layer of abstraction from compiled code, and then maybe language models are another layer of abstraction where it's natural language interface. This could be seen as, again, another layer of abstraction where instead of looking at interacting with the language model directly, it is now a type of interpreter, but this is the agents and the multi-agent framework on top of it. So that's my intuition. Do you agree with that or disagree, or like how do you think of those layers of abstraction?
Yeah, that's a very fantastic question. The abstraction is indeed at a higher level of the agent abstraction. It kind of unifies a number of different things. One is large language models. So when we use a single instance of a large language model, we usually do prompt engineering and try to give some input text and get some output text out of it. This agent abstraction can encapsulate that underneath and provide a more intuitive way to think of it as an agent that can converse with you. So not just as one single text completion inference anymore. It can do tasks, can persist some states and continue to take your feedback and produce more refined result and so on, right? So that's a large language model based agent. But there are two other kinds of backends that can be encapsulated. One is you can think of it as programming language or tool based agent, which doesn't use large language model, but they can still perform very useful actions. They can do code execution, for example, or it can execute predefined functions, or it can basically execute any programming logic you defined there. And third one is the human kind of backed agents. So these agents can be considered as some kind of user proxy. So when they need human input, the human can take over and just participate the multi-agent workflow as one of the agents. So you can think about several agents. Some of them are large language model based, some are tool based, others are like human based. So that they can just cooperate together through a very natural interface, which is a conversational interface. So that's kind of layer of abstraction we provide.
Yeah. No, I appreciate that. And I'm reminded of during, I think it was the Ignite keynote speech, Satya Nadella said, think of it as a reasoning engine and a natural language interface. And that was like the two simplest ways to think of generative AI, at least the language side. So the other topic that I wanted to ask about to kind of dig into was thinking about it as a kind of automation. So there's the agent based, there's the tools based, but then overall, kind of, and this is a messaging, kind of a framing that I've adopted when talking to people is, and of course it's an oversimplification, but AI is not new. Like machine learning has been around for a while. This is just a step function in terms of capabilities that models have, but it's also just the simplest way to think about it from a production standpoint or from a software standpoint is it's a new suite of automation tools, right? That's kind of how I think of it. Is that a fair characterization, or is there something that I'm missing from that? Because I do feel like there might be something missing, or something that characterization doesn't fully convey. But it is still fundamentally new automation, right?
It's so if you try to understand it from automation point of view, I think agent is fundamentally a automation concept. The automation is more like about, instead of giving every detailed instructions using code, let's say step 1 do this, step 2 do that, using from precisely defined programming language specification. Now we can make some more vague specification using like natural language specification. Say I want to accomplish certain task, and could the agent do it for me? So and then underneath, the agent needs to kind of break down a big complex task into maybe smaller solvable tasks, and until each task can be conveniently solved by a simple inference and produce a corresponding code to solve that task. And then eventually we need to recompose them, all of these intermediate steps, and get to the final output back. So that is one part of the automation story. And another part of it is, think about this, automating some tasks that human had to do. AutoGen really started with some very simple kind of automation. Just think about how you use ChatGPT. You as a human need to ask questions, and ChatGPT give you some answer. Sometimes it give you the code, and then human need to take that code, right, and run it by yourself and get some result. If it's not correct, you send it back, and ChatGPT give you some revised code again. And here in this kind of interaction, humans do need to do a lot of work. But many of the work can be automated if we use agents. And even some kind of human feedback, like non-code. If say if I don't like the results, but I know my preferences, I will tell it, such as change the chart from using dollar to percentage, that kind of requirement, or teach me this lesson, teach me about math, but using a concrete money example, right? So that those kind of requirements can be somewhat automated using all different ways. Sometimes we can use larger models. Sometimes we can use some retrieval augmented approach to information retrieval to get the knowledge from somewhere. That's kind of another kind of interesting automation we can make. Yeah.
Yeah, no, and within that, those automation stories, because you know, some of the examples, what was it? How did you say it? Like a kind of a vague specification, right? A natural language specification that is not quite as rigorous as, you know, software development might have required in the past. And then, of course, with these models, they have the ability to kind of think through it, or, you know, break it down into steps. So with all that, and some of the work that I have found is, or some of the problems that I've confronted, because it can think in general principles. It does know a lot about software development, and I mean, the language models know a lot about a lot of things. So with respect to AutoGen and kind of getting to where you're at today, what are some of the biggest challenges that you've overcome so far, or that you haven't overcome? Maybe that would be a more interesting story.
Yeah, sure. I can talk about both. For what we have overcome, I think we have kind of figured out the abstraction I told you earlier about how to unify these different types of capabilities, different ways of making them work together. We have found one very simple interface that can accommodate a variety of different communication communication patterns. So one example is so there are several examples. One is the simple like one-to-one conversation. Another is hierarchical chat. Like suppose one agent is more sit on top and talk to several sub-agents it manages, and they can be nested structure, hierarchical structure. And another example is multiple one-on-one joined chat. So there's no one that is strictly sit on top. Everyone talks to everyone else, but it's multiple one-on-one which are connected. So I talk to you, you talk to Katie, Katie talk to me, and this kind of triangle or multiple joint chat. And there's also a group chat, meaning it's not a one-on-one chat anymore. So everybody send messages to everyone else. So we see each other's message. And there's a hidden group chat manager which does this kind of work. So architecture-wise, it's still like one chat, but on the surface we can create a experience that simulates the group chat, and we can nest it the chat in some way. Like for example, we can start with a one-on-one conversation now, but at some time I decide to consult Katie. And so I will hold on my current conversation and have some conversation with her. And then after I finish the conversation with her, I get back and continue the conversation with you. So that is one kind of nested chat. I believe that essentially you have the building blocks right now, right? These are some very common building blocks, and we compose them together in different ways. We can build really complex workflows in general. So any arbitrarily complex communication patterns can be essentially built up using these building blocks. So I think that is what we have achieved, and we have also many examples for different applications of using these different type of patterns. This is another thing, second thing we figured out, and the third thing I think is the ability to take human input and human control in a very natural way. And I told you earlier, it's like every agent can be configured to have to enable the human input or disable that depending on like what you need. And also you can decide the type of involvement from human. You can take over every time, or you can only selectively chime in at certain time. So that's a very useful feature, because when you develop this automation, even initially you don't know which step is easy to automate, and which step is necessary for a human to get in. So you can start from the more human in loop way, and when you figure out that one step is you can confidently automate, then you can gradually reduce your human intervention, right? So this convenience is very useful for like doing all the experiments and figure out the right way, and still make sure that human has a control when they need to. Okay, this is the third thing. I think so one more thing is the modularity and the reusability of the agents. That is very important design part of it. So make sure like if you develop one useful agent in a different application, you could either directly reuse or selectively modify it or extend from different ways, and make sure the previous hard work is not lost. I think that's also very important thing when we like work together to build more and more complex applications. These are a number of things I think we're kind of figure out, and there are indeed a lot of challenges we haven't. And yeah, shall we get to that part?
Yeah, no, I just want to reflect on you know, some of the processes that you outlined, like removing humans from the loop step by step. Back in my time as an automation engineer, that's exactly what I would do, is like, okay, I can, you know, I write a script that does one part easily. Cool. Now what's the next part? And then where do I have to jump in? And some of the other problems that you solve, like knowing, so this I think is really important, because some of the members of my team and my projects have found the same thing, is that knowing when to be quiet, knowing when not to jump in is in many respects more important, because you don't want to end up with too much noise or wasted tokens. So that's really fascinating. Before we talk about problems you haven't overcome, can you talk about some insights from that, like that inhibition signal, or you know, keeping the noise lower? What were the key insights there? Like, how did you test that and figure it out? And do you have any general principles for anyone else building agents?
Yeah, this is a very good question. This is also related to another question about when do you add agents to provide the feedback, and when that is not helpful, right? Because I assume the noise you're talking about is when you add more agents to serve as, for example, critics, or more agents that try to refine what the other agent is doing, right? They serve as a channel to provide feedback, but sometimes that feedback can be misleading and actually prevent the original agent doing the right thing. Yeah, we do observe that, and also it's not like the more agents the better. It's not necessarily that. For example, if you use GPT-4 as the backend for a assistant agent, for a large number of problems, you need a simple two-agent workflow. One assistant agent, another user proxy agent. Yeah, probably I need to explain what a user proxy agent is. Basically, it refers to what I meant earlier about automating some of the work that human does. For example, using tools to execute Python code or run some predefined functions. So if you use one GPT assistant agent to suggest a solution such as code or function, and use another user proxy to execute them and just provide the feedback back and forth, you can solve a large number of problems very well. And some of them are also complicated and can involve multiple steps. But if you use GPT 3.5 Turbo, then it's much less to work in this way. So adding more agents will be much more helpful. And even for GPT-4, when the problem complexity goes to above certain level, it stops to follow the many instructions, because the trick for one single agent to work is actually put a lot of helpful instructions in the system message and make it know how to deal with some complex situations. But we noticed that if you put too many of them, even for GPT-4 and for complex tasks, it will start to forget these instructions and not do things as you want. Otherwise, you can just give it simple instruction to say try your best to solve the hardest problem, and then it will be done. It's not we're not there yet. In future we may. This makes me want to bring up one interesting kind of law a few of us came up called Gabucci's law. The law has some similarity with it's an analogy of the Conway's law in software engineering. I'm not sure if you're familiar with that notion.
No.
So Conway's law basically saying the complexity of the software or the architecture of the software is a reflection of the organization that makes the software, that builds the software.
Okay, makes sense.
Yeah.
Yeah.
So our Gabucci's law says the model complexity will affect model complexity or capability, which will change the topology of the ideal multi-agent solution. It's a summarization of what I mentioned earlier. If you use a more powerful model, then the likely you can use simpler topology of multi-agents to solve a complex task, and vice versa. And also, I think we need more research to understand this better. It's not solved. I'm seeing like people trying all different kind of topologies or communication patterns for different applications. They're very creative. And what we haven't figured out is what is the best topology and for a particular model and for a particular application in a kind of a very clear way to answer that question. We're not there. And this is one of the actually big challenge or big important problem we want to solve. Yeah, next.
Yeah, no, well, first, thanks for sharing some of those critical insights. Yeah. And so I guess the general principle is the smarter the underpinning model, the simpler the topology can be, because the more complex the instructions can be, and the more complex the tasks that an individual agent can carry out. When saying it out loud, it seems kind of obvious, but that's a good rule to generalize. So yeah, I guess let's pivot into what are some of the remaining problems? What are your biggest challenges that you either are working on or are going to be down the road? You mentioned topologies, like figuring out like what is the correct topology, and of course, like I can imagine that it's a moving target, because as the underlying models change almost on a monthly basis, you get new and different capabilities that kind of maybe send you back to the drawing board sometimes.
Yeah, this is why like having a framework that is versatile, that is flexible to do the experiments is so crucial to kind of do the fast adaptation, right? As the model moves, as prompting techniques advances, and as more and more small models, specialized models are available, they will probably also change a lot about what's the best way to build applications. Yeah, so this is I think the big value of AutoGen. And for like unsolved research questions, there are some concrete ones. I can give a few examples. One is about this decomposition problem. As we mentioned earlier, we want to be able to achieve a state where the human can or human only needs to specify relatively big ambitious goal, and underneath we want the agent to be able to decompose that into solvable problems, probably multiple layers, and eventually recompose it, and solve each of them and recompose it. And during this process, there are situations where the human need to provide like clarifications, because the initial one can be ambiguous. And we want the human to only provide the necessary, minimal kind of necessary clarifications and instructions, and let the agent to figure out the rest of them. That is a big challenge, because if we want to solve more complex problems, we have to have a principled way to do this. And the second question also related to this is, as we solve bigger and bigger problems, how do we do proper validation of the intermediate results? Because if we don't do that, it's possible that the agent will kind of stick to some wrong intermediate results and then just keep wasting, right, their work. And at a certain time, people need to provide validation or use agent to do self-validation. That's hard, but ideal way to do it. So we probably need some formal language or formal way to do this proper validation, so that the automation can indeed happen in a way that human desires. Yeah, so these are some just two kind of concrete pieces of like problems.
Yeah. In my project, we almost started in the reverse, where we started with oversight of steering and oversight and supervision.
Yeah.
So I'm curious, what's your perception or research or findings with respect to, because you already mentioned like having like an assistant agent, and then also having kind of a top-down hierarchical agent where you've got subordinates. What do you think about like kind of my intuition that working towards having supervisors, steering, QA, quality assurance kind of agents throughout the network of agents that are capable of providing some of that feedback that you mentioned earlier? Is that kind of the direction that you're going, or have you tried that and it didn't work? Or like, what are your thoughts in terms of having some of those specialized roles or personas as a way to help along?
Yeah, there are some examples that work pretty well. I can share some of them. One is a 3-agent setup to solve a multi-agent coding scenario. The application is for supply chain optimization. It's done by another MSR team. But that solution, in my view, is quite generic. It's not restricted to that particular application. And the setup is like, it's a hierarchical setup. There's a commander on top. There's a writer who is responsible for writing Python code. The agent can also have access to some proprietary tools like optimization tools. And the other sub-agent is actually Safeguard. Safeguard is in charge of reviewing code safety. So the way it works is that the commander receives some user's question. It will first ask the writer to write the code. And after receiving code, it will ask the Safeguard to review the code for safety. And only if the safety criteria is met, it will run the code and send the result back. Otherwise, it will just ask the writer to rewrite the code. And this can go back and forth because there can be error. So we need to debug. The writer can do that until the result is correct. The writer comes back with the final answer, natural language answer to summarize the result, and the commander returns that to user. So this is almost the quite simple kind of multi-agent setup, but very effective in our application, almost 100% correct every time. One kind of lesson is if we merge the capability of the writer and the Safeguard into one agent, it doesn't work that well, especially in the code safety part. So we have the experiments in our paper. We found that if you merge them, then the accuracy for detecting code safety issue will drop significantly, both for GPT-4 and GPT-3.5 Turbo, but more significantly for 3.5. So this kind of hints that one agent, if you ask to both suggest a solution and check the solution suggested by itself, it will have a bias.
Right.
But we separate them and also prevent them to talk to each other, kind of make them work in an adversarial setting. It does it better. So that is one observation. But we also have other kind of scenarios where we do involve every agent in one group chat, so everyone also sees others' message and can reply back. It also works sometimes for other tasks. For example, a critique to suggest a visualization criteria for a visualization task. You can have one agent write code, another to criticize. It sort of works, but my intuition is still that if we put every agent work together always in a group chat, it may not always work because they may have a tendency to agree with each other instead of trying hard to challenge. I would say it's case by case for different applications because there's also some like benefit of using this group chat because it's relatively simple. You don't need to do very hard about handling the message separation. You can put simply define your agents and put them in the group chat and get them running quickly. So that's one benefit of group chat, and see many people are using that approach. But just to be careful that it may not always work because of the limitation of the models. Yeah.
So that's really fascinating to me, and my my intuition was the same, but it's interesting to have that validation from another perspective. So it's almost like even though the underlying model is GPT-4 running all of the agents or 3.5 turbo, there's still an effect, like a positive effect from using division of labor, right? Which the division of labor comes from the history of human work.
Yeah.
And so just taking a moment, obviously these models do not work like human brains, but when you have an agent with a very specific task and mission and set of success criteria, that effectiveness of the division of labor it still helps, even though it's just activating the latent capabilities within the same underpinning model.
Yeah.
And then another intuition or a principle that I want to reiterate is the idea that in some cases group work makes sense, but in some cases it doesn't. It's almost like the same difference in humans where the power of introverts, right? Doing solo work on your own versus doing collaborative group work. So again, not saying that they're operating like humans, but it's really interesting to see some of these parallels emerge between multi-agent work and the nature of human labor.
Exactly.
So yeah, very, very fascinating. And it's interesting because in some of the conversations that I've had and some of the observations that I've made, it's almost like what we're doing with these groups of agents is recreating like a corporation. Like you might have like a CEO or a boss or a supervisor, and then you have the coder and then the QA. So it's very similar structure. So do you have any other major insights or lessons that you think are either recently or super valuable that you want to share with other researchers or that you would recommend?
Sure. There are so many of them. I can give you a few examples. One thing is the chat, the conversation perspective. I mentioned earlier that ChatGPT is a big inspiration, right? And it's certainly for many people. But for me, there's a personal story about what specific inspiration I got from it. It's a reminder of something I learned back in my college from a professor who told me that conversation is a provable way of making a good progress of learning. I don't remember the exact quote of that, but it's roughly that. So basically, he's trying to say conversation is a very powerful form of either learning or making progress or etc. That many people didn't realize it's how important it is, and there's some theoretical root there. So that's one reason I'm so kind of so sure or so I have so much belief in using conversation as the central medium of the like a multi-agent interface. Again, I know there's a science, although I didn't have time to find out like which reference it was, but I know that, so it gave me the confidence or the belief. Yeah, this is the right thing to do. I think one of my collaborator co-authors, Jimmy, actually found me some reference from a social scientist. He mentioned something similar to that. Yeah. So this is one. I think one lesson, one kind of unique thing that I don't think many people have really. They kind of understand ChatGPT is very powerful and also get a lot of useful experience from that. But maybe this science part of it is less known. So that's one thing I want to share. Another inspiration source, as I told you, so AutoGen is really inspired by many different things, many projects I've worked on before, and all the lessons I've learned. So another one example is operating system. So this is also not so obvious when we talk about AI. Why do we talk about operating systems? I think the The several things, several inspiration I take from the success of operating systems. One is like the idea of maximizing the utility of the most valuable resource you have. So in the old days, it's like the CPU, the GPU, but I think in the new era of AI, these powerful large language models is so valuable resource, and building a operating system around them, right, and maximize their utility, but give them the necessary peripherals, and do the right coordination of, is super critical from the system point of view. And also, so that operating system is really, you can build a platform that can support many diverse applications on top of that. So we need to design a very generic, robust kind of system to do that, right? So these are all the design principles we try to use when we design AutoGen. And similarly, the idea of object-oriented programming is very useful. So many developers have very interesting ideas they want to try and develop. And now with this framework that hides a lot of complexity inside the framework, they're able to kind of do the things they want more easily. That's the power of abstraction. I already mentioned the agent notion, the automation inspiration. The one thing I want to mention is open source, right? The success of open source is that it can solve a common problems that community needs and make it really easy to use, right? So those are the probably most important kind of things that can kind of get good open source adoption and build something that community loves, right? Yeah, so I think that is one valuable lesson I want to share with all researchers, right? If you want to get their research adopted and get more impact and influence, and through this open source channel, then spend a lot of effort to about the usability and solving the common problem that many people want to solve is worth considering. Yeah.
I have personally found success in giving away as much valuable information and ideas as I can. That's what my whole YouTube career and computer science career is based on now. So thank you for sharing those critical insights. So on the topic of operating systems, because I'm really glad you brought that up, because I started thinking about language models as a component, like a new component of an operating system. So I'm glad to know that there's some convergence there. Is that kind of the future of AutoGen? Is that what you're looking to move towards, is kind of being the operating system or a major component of a future operating system that uses language models as like kind of the new CPU, and maybe retrieval augmented or some kind of storage as like the new memory? Is that kind of the direction that it's going?
Yeah, exactly. So it's my ambition. It's when I started working on AutoGen, I discussed with some systems friends working on the systems. I told them this idea, and yeah, it sounds a very ambitious idea to them, but I can see that some people really like this idea, like and even some very senior people will give me very strong support of this. He kind of having that idea independently. I kind of see that some of the most visionary people also realize this, and definitely we want to pursue for that. Yeah.
Excellent.
Yeah.
So taking a big step back, just in terms of the direction of research, I think, I don't know if it's official, but the rumor is right now OpenAI is working on GPT-5, and then of course Google with Gemini and Meta, like everyone is working on bigger and bigger models now, and so we're going to get more capabilities on this. At the same time, smaller models are becoming more efficient. So Satya Nadella announced small language models coming, so that way you can probably perform very small cognitive functions, but very quickly and efficiently. So what are some of the trends that you see intersecting with like your work around AutoGen and agents and agent swarms? And what I mean, I guess to be specific, is maybe cost changing or new capabilities coming. Like, are there any capabilities that you're really looking for that would make your job easier? What are your thoughts on some of these new capabilities and making these agent, multi-agent platforms more autonomous? Or is that a good idea, a bad idea? So very kind of open-ended question. Like, what do you see coming this time next year?
Yeah, I think the idea of having specialized models to perform certain tasks in an excellent way and in a cheap way is fascinating. It's indeed worth a lot of investigation. For example, some of the hard problems I mentioned earlier about the decomposition, recomposition, validation. It's possible that some specialized model can do these kind of tasks really well, or we haven't seen that yet, but conceptually that sounds like a possibility. Actually, I'm pretty surprised that we haven't found a special model that can solve this. So it makes me kind of wonder why, right? Because theoretically, this is such a natural idea that if you fine-tune a model that can do certain things, you should be able to do certain tasks very well, and you can just replace one specific agent with that. And also, many people are trying that. I know either there's some fundamental reason we haven't figured out why it's not why we can't do that, or we should be able to see that pretty soon, right? It's just, I think it's only one of these two possibilities, because the former possibility is still there, because the small model, it's possible that the small model lacks some very important capability of being fine-tuned to perform these hard tasks, because these tasks are not easy, right? The decomposition problem, I think even the GPT-4 model is known to not to be too good at planning, right? It can do some kind of planning, but not perfectly. So if you want to get better capability than GPT-4 in some specialized tasks, it's TBD. It's to be seen whether we can accomplish that. But if we lower the target, if we say let's train some small models that can do something GPT is already good at, that is much more amenable. I think I already see evidence of that. So then it's more like a cost reduction story. So that is, I'm pretty sure that's feasible. And the other part about getting better capability than the big model in some aspect is to be kind of we have to hold our scientific curiosity and see what happens. Yeah.
That makes sense. We are almost out of time, so I want to respect everyone's time. And so I'll just say, like, thank you so much for jumping on and sharing some of your thoughts. I'm super excited to be along for the ride. But yeah, before we close, I'll give the floor to you. Is there anything that you'd like to put out in the world? Any personal requests or personal hopes that you want to share with a broader audience?
Thanks for giving the community the opportunity to do that. Yeah, I want to say that we are still early, right? At the new age, agent becomes mature software that can do a lot of things for us. We want to build the future together with everyone from the community. So give AutoGen a try. Try to use it for applications. Let us know what's working and what's not. We are very happy to work together to improve it and answer some of the big important problems as we mentioned. And I really want to acknowledge that all the contributors, starting from the original AutoGen paper to the recent more open source contributors joined together, and the huge developer community that's supporting us. I really learned a lot from everyone who has used and provided feedback. People are super creative. I think this is the right way to solve the hard problems, and hope to continue to do that and support the community, support everyone. And for example, the effort you're doing with the hierarchical kind of agent swarm, right? It's a very good example that you're making certain bets on certain kind of ways of making it work. I'm very curious to see how that experiment goes, and if AutoGen can be of any help in this or other kind of similar efforts, we'll be very happy to kind of support you if you need any feature, any kind of useful infrastructure support, that kind of thing, yes, let us know.
Yeah, absolutely.
Yeah.
No, we're definitely looking forward to continuing the collaboration. I think that, as you said, there is a lot of work to do, and there are some limitations. The model's limitations today are the model's limitations. There's not a lot we can do to work around that, but it is just the beginning, and that's one thing that I'll use the closing to say is, remember where we were a year ago today. ChatGPT was probably published just about a year ago. But before that, it was GPT-3, GPT 3.5, and the distance that we've covered in just the last year is like, it is a privilege to be part of one of the greatest shifts that humanity has ever seen. And some days it doesn't feel real, and some days it feels a little too real and a little too overwhelming. So thank you, Xi, for helping make this a reality and spending some time talking with me. And thank you to Katie for helping put this together. And yeah, so thanks everyone. And yeah, see you all next time.
Thank you so much. Appreciate it.